I am Mohammad Jalaluddin. I am a DevOps engineer at Edly. With me is Hammad Daoud. He is also DevOps engineer. We both work at Edly in different capacities. So the topic of our case study is how we scaled OpenEdX to 50,000 concrete users on Oracle Cloud. Before starting that, just for an icebreaker, how many of you are familiar with Tutor? And how many of you have deployed it in any capacity, Tutor local or production? Cool. And how many of you are familiar with Kubernetes? That's so the agenda which we are going to take today is we'll start with introduction of Tutor. We'll discuss briefly about different deployment methods of Tutor and how we can set up Tutor. After that, we'll try to dig deep into the architecture diagram and different components that we used in our solution. And later on, we'll cover why we chose Oracle Cloud instead of AWS or any other cloud. In third section of our case study, we'll discuss about optimizations and load testings, the infrastructural constraints that we faced, and how we overcome those. And at the end of the third section, we'll discuss about the load testing, how which approach we took, and how we completed that. And at the end, we'll end the session with conclusion and QA. Hopefully, you'll have questions for us at the end. So, what is Tutor? Tutor is, as most of you are aware with Tutor, so it's the official Docker-based OpenEdX distribution, both for production and local development. The goal of Tutor is to make deployment easy, upgrade and scaling easy for everyone. So if you are not very tech savvy, if you are not a DevOps engineer, as I'm sure not everyone is related to the DevOps field here, but as you guys are aware with Tutor and you have used Tutor, so it does tell us that it's easy to use for everyone. Tutor is reliable, fast, extensible, and it is already being used by hundreds of OpenEdX platforms around the world. So how can we deploy Tutor? So there are basically, it's very simple. One is the basic Tutor part is for development, which is used by developer to do development on top of OpenEdX. So that is called Tutor Dev. So you can simply launch it with Tutor Dev launch command. It's as easy as that. So the local deployment, it's the use case of local is you can it uses Docker Compose to start containers on a VM. So it just requires a single VM to run. So you can use it for testing or for smaller workloads for small clients. It's not recommended for medium to large scale clients, of course, because it has no high availability or any of the stuff. If you want to go into that part, you'll have to, explore Kubernetes, and it is recommended officially. It's not recommended for large scale applications at the moment, but we have tested it and we feel that it's comfortable to use it for large scale applications as well. As the case study, we have completed the 50,000 concrete users test. So setting up Tutor on local, it's as simple. It's pre-compiled binary is available on GitHub, or you can install it via pip package. By default, Tutor saves its configuration in a path you can see on the screen, local share Tutor. You can also change that path according to your requirements by an environment variable. Once these steps are done, you can simply run tutor local launch. It will pull all images of the services that are available. Then you'll run tutor local start in the background. So it will start all the containers. But when you are doing it for the first time, you'll have to run an initial command, which is init. It will initializes all applications, create necessary database tables, and it will apply all the migrations. So the next part, how you can set up it on Kubernetes. It is compatible with all famous Kubernetes providers, be it AWS, GCP, Azure, or Oracle, or you can also deploy it on-prem. And its installation is as simple as you'll have need to have Python and pip, and you can do that. It saves its configuration in local share tutor and a YAML file. You can change all the configurations in that YAML file. Once you change your HTTP host or anything like that in the YAML file, you can save the configurations and then just launch tutor k8s launch, and it will launch. So now we'll dive into the architectural part of this, and I would like to hand over the mic to Hammad.
Hello, everybody. So I think all of you are familiar with the components of Tutor. There is LMS, Learning Management System, and these are the components. Yeah, okay. And these are the microservices or components of Tutor deployed on Kubernetes. So first one is LMS, then CMS. LMS is you all know Learning Management System, and this is the landing page of learners to access their courses. And then there is microservice of CMS, and CMS is for content management services, and this is for authors to build their courses. And there is a WordPress service. We use it for a landing page, and then discovery services, credentials for credentials management, Karen, Minio, workers for LMS and CMS workers, and then there is a forum service. So these are microservices we have deployed on our Kubernetes engine on OKE. So on Oracle, you get different microservices, managed services. There are like the first one we use for deployment is OKE. So it's Oracle Cloud Engine. It's just like EKS. So it's a managed service to deploy the tutor on top of Kubernetes. Then there is a service named Heatwave. Heatwave is a MySQL service. It's just like Aurora service we got in AWS to set up databases. Then it's object storage. Its object storage is just like S3 in AWS, and for storage of content and storage of videos, just like those kind of stuff. Then we used file storage. It's NFS, network file system, and it's just like EFS in AWS. And then ALB, automatic load balancers. Then WAF. WAF is a layer 7 firewall to protect from malicious activities and suspicious websites or traffic. And then network edge firewall. It's a layer 3 firewall, and for the better security, inbound and outbound security. And then we use container registry. It's just like ECR or anything in or Docker registry. So this is for registry management. And then we use logging. So the logging services in Oracle is just like CloudWatch. So it provides us the logs of activities in happening in Oracle. This is our deployment architecture diagram. So we have four subnets. One is VPC subnets. One is for services. One is for public subnets, and one is for Oracle Kubernetes engine, and then there is for DB subnet. So um, a user come with a URL through DNS services and landed to WAF firewall. WAF will filter out uh, and traffic will go to network edge firewall, and then it will route to load balancer. Load balancer will load balance the traffic and forward the traffic to ingress services, and ingress it will route to appropriate microservice. Like if the traffic is for LMS, it will go to the LMS, and if it is for CMS, it will go to CMS. So and for logging services, yes, we are using Kubernetes logging services. So why we choose Oracle? So this project was for a Saudi-based client. So in Saudi, we had some issues with the other cloud providers like AWS or GCP. Why? Because there was some compliant issues there. So Oracle was one who fulfilled those compliant requirements. So that is why we have to choose Oracle. So then optimization and load testing. So we had some issues in deployment. So the first issue was with host capacity limitations. So host capacity limitations was something like uh, we had to when we put 50K users on our infrastructure. So what happened was after some of the load, some capacity in host was unavailable. It was like the VM was not expanding because of issue from the Oracle end, because they have some very limited VM resources at their backend. And related to this, we were getting auto scaling issues because there was some limited VMs. So that is why um, uh, the VMs were not auto scaling by default. And due to it, we get availability issues because we tried to scale up or tried to put load on different times and with different instance types, but that didn't work. So this was the issue we were getting. Then we were getting some issues related to database upgrade size, and due to single availability domain. So these were all related to actually the resource issues at the Oracle end, because they had some very limited resources at their Jeddah region. And we got managed services availability issues in Redis and Elasticsearch as well, because all of these managed service at backend, they use CPU resources or memory resources. So that is why the main issues was with the Oracle, with their CPU and other resources. And we tried to contact their customer support, and we were getting issues there as well, because they were saying that issue was not at their end, it was our end, and it was back and forth calling them. So challenges and approaches. So we had adopted evolving approach to understand OK cluster behavior, including nodes, pods, and Nginx ingress. Um, it was like we observed, we put the load on our infrastructure, we observed the behavior, and then we adjusted our limitations. Sorry, our capacity. So this was how we were adopted the evolving approach. Then I iteratively tuned components based on their observations and bottlenecks. The initial attempt at horizontal autoscaling of LMS ports was inefficient, and it was ineffective because of host capacity issues, and we get specific bottleneck made scaling out with smaller pods inefficient. So, so some of the approaches we used were we pivoted to vertical scaling instead of horizontal pod auto scaling. So the people who know about Kubernetes and its horizontal and vertical auto scaling, there are two type of scaling factors, like horizontally and vertically scaling up and down. So for the pods which on which we were getting some issues, we observed and we maintained with their vertical scaling. So and although we vertically scaled some of the pods, we still got host capacity issues in Oracle Cloud. And then continuous monitoring, observing behavior. Yes, we were continuously observe the behavior of the pods and infrastructure. And we moved higher consumption pod to specific nodes to improve performance. Yes. So some of the pods were using really heavy resources, like very heavy CPU resources and memory resources. So what we did that uh, we scheduled those pods onto some specific nodes which were higher in capacity to tackle those. So we run those pods related to those nodes. So to manage this and tackle this issue. Challenges and yes, continuing to challenges and approaches. We Kubernetes optimization with dedicated node groups for pods and nodes auto scaling. We use chains and tolerance to schedule specific pods to on those specific nodes. We use chains and tolerances. And with the evolving approach, we increase UWSTI workers to optimal configurations, and we did constant changes to Nginx configurations, like limiting connections and requests, and we were doing Tutor configurations. So these were some of the configurations we were doing for the load testing. We put load gradually, increase the load, and to test that our 50K load thing is working fine. Next, going to Jalal.
So to sum things up, which Hammad described earlier, it's not like we started from 50,000. We started from 500, then 1,000, and different iterations. The issues that Hammad summed up pretty quickly, those were not handled very quickly because we had to go and forth with Oracle on too many occasions. Uh, they were relatively new to the Jeddah region, so the setup or the data center was not up to the mark as they have in European regions or US regions and other different regions. So they had limitations of hosts, but of course, no one acknowledges those. So we tried to, pin them on us. They said that you should run your workloads on a specific time where there is lesser load from the public and stuff like that. But eventually, we had to go on a call with the Oracle main team, customer success team. They released the capacity on call. We were ready. By then, we had Ansible and Terraform configurations ready. They just released the capacity for a capacity pool, and we, immediately ran the Terraform and tried to grab as much as possible. But the drawback of that was we will not be able to scale down, because if we scale down, we won't they don't guarantee that you will get the same capacity back again. So Hammad summed it up pretty quickly, but that took more time. So the load test we conducted, we used Locust tool for the load testing. It's an open source tool, load testing tool. It supports HTTP and different other protocols. It's very developer friendly, and it lets you define your tests in regular Python code. Uh, it can be run from CLI, and it has a pretty nice web UI. You can run your workloads from there. You can see your throughput, response times, and you can see it in real time, and it lets you download the report so you can later make decisions on that report. So when we started the testing, eventually when we go down to the 5,000 or 10,000 users, we started to feel that the Locust infrastructure that we had is not enough. So the workers are basically choking from where we were sending the request. So in the end, we had to use 50 worker nodes from where we were distributing the traffic to 50,000 concurrent users. And we had one master node managing all those 50 nodes. We used Ansible and Terraform to launch and manage those 50 nodes, and Ansible to start stop services and stuff like that. Apart from that, so it's really all of you would be aware that whenever you run load testing, it's not it can't mimic the real user behavior. So at the end of the day, it's still load testing. Real user would do anything. You can't predict. As some of in previous talks they have mentioned that during the semester there won't be much of users accessing the course, but when there is an assignment or a deadline, all of the users will come suddenly at the platform. So this was in the mind of the client. So they wanted the infrastructure to be ready for 50,000 concurrent users at all times. So they needed scalability after that. So we tried to explain it to them that it's not really wise to pay for that capacity if you are not using it. But it's sometimes it's really difficult to explain. So to make it more compatible towards the real user behavior, what we did is we created 4 chunks. The first chunk, 25% of the users will log in, go to the dashboard and profile section and account section. The other 25%, the second chunk, will go to the course enrollment part. They'll enroll in a course, they'll go through the course, and they complete the course, just to make it look like a real user. Otherwise, if we run a test for LMS, all of the 50,000 users will be going to the LMS. Rest of the services won't even scale, or we won't know that if they will scale when there is actual 50,000 users. So the third chunk, the 25%, will go to the courses section. They'll start a course, finish a course, and last section will go to the navigate program sections course. So we gave them weightage in Locust that this chunk will go here and this chunk will go here. So this is the breakdown of chunks that I defined in the previous slides. The first chunk, LMS, some of the users will log in, try to go to the dashboard, account section, and engage with API just to mimic the real user behavior. The second chunk, enroll courses. Some users will enroll in different courses, course 1, 2, 3, 4, and they'll exit navigation. The third chunk, navigate course, they'll navigate through the course, and at the end they will exit task execution, and same is with the navigate programs. So this is the graph from the actual load test. So what we did here is we started with 5,000 users here, and we gradually moved in the chunk of 5,000 users. So eventually we went to the 50,000 mark, and here is the response time when we started. Obviously, the load balancer or some things need to scale up before reaching the maximum capacity, and when they reached that capacity, the response time came back down to normal, and eventually we with each iteration you can see the response time is actually in the pretty safe range. So after we reached 50,000K, the response time started going above, and we feel that it will eventually choke, but as the goal was to achieve 50,000, and we felt that the resources that we have spent up are enough for 50,000. So in the last section, conclusion. So the summary of what we discussed today, we scaled OpenEdX to 50,000 concurrent users, achieved this milestone on a very challenging platform, Oracle Cloud, no bias with them, overcame significant regional capacity limitations in the Jeddah data center, addressed and surpassed underlying hardware constraint within OCI, leveraged a blend of strategic Kubernetes and application level optimizations, which Hammad has shown you in previous slides. Success was a direct result of close collaboration with Edly development team. They were, in constant communication with us. Wherever we needed optimizations, we, coordinated with them. They said that these are the configurations we think would help you guys, and we made those configurations and ran the iterations again. And then we, if we had hit another bottleneck, we went there with them again. The Tutor documentation was really helpful, and we had Regis supporting us throughout the whole section. Hammad, would you like to?
So our key takeaways were technical deep dive. In technical deep dive, gain a deep understanding of architecture and tools essential for achieving unparalleled scalability with OpenEdX, and then overcoming cloud hurdles. So we learned effective strategies for navigating and overcoming specific cloud platform challenges and resource limitations, and then finally optimized performance. Acquired actionable insights into cost efficient scaling and performance optimization technique for OpenEdX deployments. So thank you. If you have any question, you can ask us.
Hey, although we work together, but somehow I still never asked this question to you guys. Thank you. I've seen this report before, guys, by the way. But yes, I'm wondering. I saw those ratios and I saw the assumption of dividing the flow into percentages and assigning weights, but did we also change the weights? Because as you mentioned, it's unrealistic to it can't be determined what the users will what the activity would look like. But for the same reason, did we change the weights at all, or does that take a lot of time? Again, I'm ignorant of this, so.
So very fair question. No, it won't take much of a time to change those ratios, but we actually collaborated on it, and we decided that this is something that might mimic real user behavior.
Okay, but
but there is no hard and fast rule. So we just made a guess.
But do you imagine if we change the weights, will that change anything at all?
It won't make much of a difference, but it will definitely have some hit on the resource usage, because LMS has different kind of resource usage. CMS has different. We had our landing site in WordPress. We saw that if we everything was working fine, but if we hit all the 50,000 concurrent users to the WordPress, it was choking.
Okay.
So, but it doesn't make any sense that everyone will simultaneously go to the WordPress site. So that's why we break it down to the ratios. I hope that answers.
Yeah, thank you.
Thank you for the presentation, guys. Great job. I have a couple of questions. The first one is, you were mentioning that you were lacking some auto-scaling features in Oracle Cloud. How did you manage to overcome that? Did you prepare statically a lot of nodes to start receiving the traffic? And the second one is, I remember in the past, edX was supporting a library built upon Locust to perform load testing. Have you considered contributing to the open source with this amazing job you did?
So the first question, yes, we, I'm not sure if I told it before in the presentation or not, but at the end when we were running the last iteration, we had the capacity already set to maximum. So because the auto scaling at runtime won't be happening because there was no capacity from the Oracle side. So we had to fix the capacity. And we did it in chunks. So when we were running the last iteration, we had pretty good idea that this many LMS nodes would be enough, and this many CMS nodes would be enough, because we were horizontally scaling them and vertically scaling them. When we started, we ran one node on each one pod on each node, but later we came to the conclusion that it's not enough. We had to scale those to use bigger nodes. When we started using bigger nodes, they were still choking, so we increased the pod size. We gave it maximum CPU and memory. So in the end, we were on a instance of like 16 CPU cores and 32 GB memory. We were running like 3 pods for LMS, and we were running it on multiple nodes. So it's a mix of different iterations and different results that we learned from the previous iterations. So the second question, can you? It was about the
it was about if you were considering contributing to the open source.
So yes, we will definitely look into it. We haven't considered that for now, but we will definitely consider it.
Cool. I have another question, which is, do you have a rough estimation of the number of requests you were handling at the peak moment of your test?
So I don't have that in my mind at the moment, but no, I can't remember that.
Okay, no problem.
But we'll definitely coordinate later on, and I can go through my old documents, and because this was done like a year ago, so I can definitely share details with you offline.
I expect you're attending to the large instances working group, so
Yes.
we can discuss further.
Yes, that's a must. Well, we'll be seeing you there.
Thanks, guys. I think that's a very important question. The 50,000 concurrent user, great. The RPS is very much important. Request per second, whatever the max, the peak RPS, what you are handling is very much important because users come and go, but the RPS is the actual concurrency, the measure of concurrency. With respect to that, you mentioned somewhere that you have configured the UWSGI workers. Can you just elaborate on that part? Like what all
So-
exactly you have done?
So the USWGI workers configuration, by default, it was, I guess, one. We were hitting, different issues, hurdles. We tried to, brainstormed, and because there was not much of help available, so we tried to, go through every configuration. It was kind of a hit and try. We increased size, concurrency level, and eventually we came to the conclusion that if you put it to 5, it will give you optimal results for our use case, of course.
Okay, so it is about worker process or threads?
Threads.
Threads. And how many worker processes you are talking about?
So it was same, 5 and 5.
Okay. Also, in the architecture, you have mentioned that you have NFS, object storage, and min IO. If there is a min IO, then what's the purpose of having object storage?
So the min IO is actually coordinating with object storage.
Object storage of what? Oracle.
Oracle.
Okay, and NFS for what purpose?
NFS for handling the volumes of pods.
Do we really need volume for pods?
So
Unless you are having persistence layer into the cluster.
yes,
You are having
that was
persistence.
the reason. Yes.
Oh, okay. And what
Because
about
one of the other reason, I think you might have skipped, the Oracle didn't had some of the managed services like we usually get in AWS, like Redis, Memcache, Elasticsearch. So they were available in other regions, but they were not available in the Jeddah region that we were running into. So we actually moved those workloads inside the Kubernetes cluster. So for that, we had to use NFS to make it persistent.
Sure. Last question.
Sure.
You mentioned HPA was not possible. What was the reason for that? The horizontal pod autoscaling.
So it was not possible due to the issues at the Oracle end. Not generically meaning it's not possible, but for our use case, because we were whenever we tried to let it autoscale on itself, we hit the wall of the capacity issues. There is no capacity to launch another VM or node. So that's the reason.
All right. Thanks.
Yeah, I think this is phenomenal. So, guys, thank you for a fantastic presentation. So, given all these technical challenges, one, you did mention that AWS and GCP perhaps were not the
Usual choice.
were not the choice in that case because of the compliance or whatever reasons. But have you had similar experiences with AWS on many high volume transactions and concurrency in the past? And if you did AWS also had some of these challenges?
So not specific to Tutor, but we have prior experience for some of the other applications that we work at in Edly. We have scaled Moodle to 50,000 granted users, and as you guys use AWS, you know that with AWS you don't face such challenges. There is ample capacity available at all times. Maybe they are going to launch a region in Saudi probably this year or next year, and I believe it won't be as good as some of the other regions, but eventually they'll match. So I don't think so. To answer your question, I don't think so. We'll be facing such issues at AWS.
Okay, one other question. Given some of these constraints, especially with relation to maybe data, did you guys consider the hybrid cloud approach, having the compute on AWS and the data being on Oracle?
So one of the reason was they didn't wanted to go outside of Saudi region at any cost. So the one option was self-hosted or the Oracle.
Okay.
So we were not sure about the self-hosted part, because if we're facing such issues on a reputable cloud, so we can't imagine how much of an issues we will be facing on the self-hosted solution. We are not there. They have a team, infrastructure team, and we were not very sure in their capabilities.
Perfect. Now, this is good. Thank you, guys.
Thank you.
I can walk all the way back. Ready?
Guys, you were mentioning that the HPA was ineffective for you, so you decided to move to vertical, right? What kind of mechanism or technology you use for handling that vertical scaling?
So some of the pods were actually taking too much resources, like CPU resources, memory resources, and if a VM is not capable to handle that load, we have to vertically, expand on specific node that can tackle or manage those resource-hungry utilizations. So that is why for some of the microservices or pods, we were using vertical auto scaling, and for other ones, we used HPA, horizontal pod auto scaling.
So the vertical scaling was at node level.
Yes, node level.
Okay, understood. So after deploying bigger nodes, you adjusted the resources of the pod, so they were able to allocate more resources.
Yes, we were using paints and tolerations to scheduling specific pods to specific nodes for this reason.
Okay, understood.
Thank you, guys. Thank you.